Good afternoon, everybody. My name is Kevin Lamb. I'm Principal Program Manager on the Azure Application Platform team. And today I'm here to talk to you about scheduling jobs in the cloud on the new Azure Scheduler service. One of the things I'm really excited to talk about today is that the Azure Scheduler service yesterday has been made generally available for everybody. So you can go to your Azure portal and you'll find the Scheduler services there available for you to use. Some of the things I'm going to talk about today. First, I'll give you an overview of what the Scheduler service does. Then I'll go into its REST API and the capabilities that the Scheduler service has. Go into a demo, and then talk about what other services in Azure, how other services in Azure are using Scheduler today and how you can use it too. So first, let me give you kind of an illustrated example of what the Scheduler service does. On the left-hand side of your screen, you either have a client or your application that goes and generates a job. That job can be generated either through code or through JSON. In the end, it's going to be a JSON document. That document is going to be submitted to the Azure Scheduler service. That document describes the type of action that you want to have executed and the schedule at which you want to execute that job. The Scheduler service will go ahead and parse that, store it, and then remember the schedule that it needs to call it on. In the back end, on the prescribed schedule that you've defined in that job, it will go ahead and reach out and invoke the service in the back end. And that invocation can be of a service that's either in Azure. It could be on some other cloud hosting service, or it can even be on-prem if you're doing HTTP over relay, or for storage queue, you can directly access that storage queue from your on-prem service. One of the important things to note about the Scheduler service is that its responsibility is to, on the schedule that you provide, invoke those services in the back end. It does not run user code. And I'll talk about other scenarios for how you can actually host your code and what that looks like. When that job executes, the Scheduler service records the history and the results of those executions, and then the client or app can then go interrogate that history, pull it back, and see what's happened with the job, either with failures or making sure that it's successful. So let me give you an overview of the capabilities that we have in Scheduler today. On the management end, at the core layer, we have a REST API. And as most Azure services have, their primary interface is a REST API sitting on top of the service. On top of that REST API, we've published a .NET client. That .NET client is in WAML 1.0 that's been released today or tomorrow. And then on top of the .NET client, we have both PowerShell and a portal experience. As you go up that stack, we have kind of a curtailed experience, trying to make sure that we have providing the best experience for the type of interface that you're using. But at any time, if you want to get to the raw interface, the REST API always has the widest span of capabilities. Actions. So what are the different types of actions that you can do within the scheduler? The two primary actions that you can have is an HTTP or HTTP or HTTPS job, or a storage queue action. I'll go into the details of each of these actions as I go through the talk. Those actions can have an error handler, so in case something goes wrong with that action, it can handle the failure of that request. And it also has configurable retry. So you can go ahead and based on your needs, figure out the retry policy for your actions. Scheduling. When you create a job, you can create a job to fire once. You pick a particular time in the future that you want that job to fire, or even immediately. You have a simple reoccurrence. That simple reoccurrence could be once a month, every 3 days, every 5 minutes. And it can have a complex schedule. So if you want to be able to have a job that runs the last Friday of every month until the end of the year at 8:30 and 5:30 p.m., we can construct that job as well. And finally, monitoring. So we maintain an execution history of each of the occurrences of that job, so you can go in and interrogate the job and find out what's been going on with your particular action on that schedule. So being a core platform service, the Azure Scheduler has its responsibility to be highly available. That's one of the promises that we make for the service itself. We have built it out so that it's a geo-redundant service deployment. The Azure Scheduler is available in every geo-region that's in Azure today. So that includes Japan, each region, each data center in the US, Europe, and in Asia. Since we have our service deployed in all those data centers, we also have failover for each of those. And in case one of those happened to be unreachable, access to the service is still made available in another data center. Geo-regional job replication. So not only is our front end available for your management requests coming in, but the jobs that you have given us to execute will also be replicated to ensure that in case something happens to one of our backends, or there's some type of outage that we can't reach out for those jobs, then we fail over automatically to another data center in the same geo region. So for example, if you've created a job in South Central, we'll go ahead and replicate that job to North Central, and if anything happens to South Central, we will automatically run that job for you North Central. And so each data center is paired around the world. So we have East and West US, we have North and West Europe, and Japan East and West, as well as Asia Southeast and East paired. So we make sure that the data stays within the geo region, but it is made highly available. One of the things that we wanted to ensure is that you didn't have to worry about how to make your jobs highly available in our service. There are other services out there where you'd have to think about, well, if that job went down, I have to make sure I have a duplicate job someplace else and disable that job if it's down and enable it someplace else. And you don't have to worry about that management. We take care of that for you. Job reliability. So we've made our guarantees about our service and making sure that it's highly available. But we can't make that guarantee about your service. Your service has its own behaviors and capabilities, but we wanted to make sure that the schedule service is going to try as hard as it can to make sure that that job executes successfully. So the first thing we have is a configurable retry policy. Your back-end service that we're trying to reach out to could have service windows and could be down for an hour a week. And if you have a job that's really critical that happens to execute at that particular time, you don't want that job to fault and wait another week to execute again. So you can go ahead and configure that retry policy to be as aggressive or as loose as you need to make sure that that job executes and doesn't miss its scheduled execution time. Out of the box, we have a default retry policy. That default retry policy is to try 4 times every 30 seconds, but you can expand it to 10 times once a day or once an hour, or whatever that time span is that you'd like. Alternate endpoint configurability. If for some reason the endpoint that we're trying to reach out to that you've configured in your job becomes unreachable, either the service is down or there's a network outage, the schedule service will realize that it cannot reach that, and if you configured an alternate endpoint, we will go ahead and swap over to that alternate endpoint. So we've given you the ability to have your high availability for your service without having you to build in all the infrastructure for your front end to enable that for us. We've taken that workload off of you. So in this diagram, you see that the Azure Scheduler service is going to try, based on its retry policy, to hit that New York web service. After all the retries have failed, it will go and check if it has an alternate, and then go ahead and start making requests to that alternate with the same retry policy. So now I'm going to go into the REST API, and then it will describe its capabilities for what the service can do for you. So at first, the REST API is our core API for being able to integrate with our service. It is proxied by the Service Management API. So all services that have a management layer are serviced through the Service Management API. There are some services that have a data management layer, for example, storage or SQL, and those have their own data plane for making requests to those backends so that you don't have to go through the front door of Azure to make those requests. And the inbound security is based on the Service Management API, so whatever the Service Management API provides for you is the security that works for us, so the authorization, the authentication, for example, is with subscription certificates, whatever you can authenticate with the front door with. So looking at the entity hierarchy, at our REST URI, you can describe what that entity hierarchy is. So I'll go through each of these parts and describe what that hierarchy looks like. So at the top layer, we have job collections. Job collections is, as the name implies, a collection of jobs under your subscription. And I'll go into the details of each of these as we go on. Then you have the set of jobs in that job collection. And I will go ahead and describe what a job looks like. And then for a particular job, you can look at the history of that job. So the REST API gives you a clear way of being able to navigate to the REST resource that you need to be able to either interrogate, create, delete your jobs in the service. So the first one, job collections. Job collections is the Azure resource that you create through the Service Management API. The intent is that it's created by the subscription owner. That job collection resource can be seen as a unit of organization or management. So you can, if you have a back-end application that has a number of jobs and you want to associate those jobs together, you can create a job collection and put all those jobs in that job collection so you can delete them together. Their lifetime will be managed all together. You can stop those jobs. A job collection is constrained to a region, so all jobs that are created in a job collection all run in the same region. A job collection can have a quota. So the quotas that we've provided are max jobs or the max recurrence for those jobs. So for max jobs, you can indicate for a job collection that it can only have 10 jobs. And then the 11th job will fail when you try to create that job in that job collection. Or the max recurrence, you could say, hey, I only want jobs in this job collection to run once an hour or once a day. This is useful for applications that want to integrate the scheduler service so that you don't have to remember all those rules. You create the rule in the job collection, and then when you try to create the job, you'll get the appropriate error back that your app has exceeded its quota for that job collection. And at the bottom there, I have the URI so that you can see where you can actually create a job collection by doing a put. At the next layer down, we have our jobs. The jobs is essentially a JSON-defined document that helps you describe the scheduled job that you want to execute. So it has an action. That action describes the type of invocation that you want to have. You can have optionally an error action and a retry policy. I talked about that in job reliability. Of course, you want to supply a recurrence for that job. So is it once a day, once a minute? How long will it run for? Will it run 10 times or at the end of the month? And then a state. So you can create a job in the disabled state if you want, or you can, by default, it gets created and it's enabled by default. The content that you put into an action is secured when the job is at rest within the scheduler service. So a lot of times when you have to reach out to your backend, you may have secrets in that job definition, and we want to make sure that your secrets are safe within that job definition. So when you give us that job, we will encrypt that action so that at rest, nobody can actually look at that data. And again, here's the URI. As we go from job collections, now we have the child set of jobs. So a job action. So I'm going to go into the details of now the job itself and describe what each of the parts can do for you. So the job action describes a type of service invocation. So that service invocation can either be an HTTP or an HTTPS endpoint, or it can be a storage queue. So we can send a message through a storage queue or send a web request to an HTTP endpoint. This is the action that is invoked on each occurrence of your job. So if you set up a schedule for once a minute, that endpoint is going to be hit on that schedule by the defined job action. Job authentication. So in your job, you may want to be able to ensure that you have the right authentication for the service that you're talking to. For storage queues, we have a built-in model for requiring SAS tokens, so that one is that we're ensuring that you have min privilege. SAS tokens allow you to set that privilege, and for the scheduler service, all we need is add message access permission. So we won't do anything else with that queue besides add messages. And the SAS token can also be revoked and can expire. So you can match the SAS token with the lifetime of your job and have more confidence than giving away your storage keys to everybody and having that replicated everywhere. For HTTP jobs, of course, the recommendation is to use HTTPS so that it's encrypted over the wire. We support basic auth. So you do a base64 encoded username and password, and you add it to the authorization header of your request. So this is the common protocol. In the portal, we've made it convenient for you, so you can just enter in username and password, and we go ahead and do that base64 encoding and stick it into the header for you. Another model that some of our partners have used is with web requests to use a shared secret. So you can create a secret, such as a hash of the job URI and a shared secret that the backend knows about. You add that secret to a header that's in your job, and then when the backend gets it, it will interrogate that secret, break it apart and see that the shared secret's the same, and verify that that request came from the scheduler service itself that you've created on the front end. So of course, it's important to have on a scheduled job actually a recurrent schedule. So here are the things that you can define in your schedule. You can define a start time. A start time is optional. If you don't specify a start time, it will start immediately. But it's some time in the future for the first occurrence of the job that you've described. The frequency, so the frequency can be minute, hour, day, week, or month, and we'll run at that frequency at the given interval. So if I want it once a minute, every 5 days, every 3 months, that's the interval that you supply. And then a prescribed rule. This is where you get into more complex schedules. So you can describe which minutes that you want it to run at or which hours that you want it to run at. For example, I only want it to run at 5:30, 6:30, and 7:30 every day. You can specify the weekdays. I only want it to run on Mondays. You can specify month days. I only want it to run on the first, second, and third of the month. And then also monthly occurrences. So I want it to be the last Friday and Saturday of the month, or the second to last Friday or Saturday of the month. You can specify all those things in the prescribed schedule. And then lastly, we have a completion rule. So that completion rule allows you to describe the semantics for how the job will complete. So you can either have a count of occurrences. So I only want this job to run 10 times. You could have an end date. I want this job to only run through the end of the year, or I want it to run till tomorrow. Or you just don't supply any, it'll run infinitely. Error handling. So as I described earlier about job reliability, we've given you error handling capabilities within the scheduler service. So you can define your retry policy. We have a default retry policy built in if you don't specify one, which is try 4 more times every 30 seconds. But if that's not the one you want, you can override that with your own retry policy. The retry policy can indicate the time span between retries and the number of retries that you want, or if you want none, that works as well. And then the action invoked when the primary action fails. So this is your alternate endpoint that you want to reach out to in case the primary one isn't available to send that message to. There are 2 scenarios for that. In in the job reliability scenario I gave you, it's, in case one of those endpoints goes down, then the other endpoint can be reached as an alternate for being able to handle that workload. But it also can be used as calling an error handling endpoint. So your service may have error handling endpoint so that it can be notified that something has gone wrong with the scheduler and then be integrated into your management system to go and interrogate what's going on with that job. So if I put all this together, this is what a complex job could look like. But one of the things that's important to note is that even though it's a little long, it's actually very readable. So here I have an action that's an HTTP type of action. It's going to reach out to the URI, which is mycloudapp.net, and it's going to do a get tweets. The method is a get. I supply some headers. If it was a put, I'd have a body. I define an error action. That's another HTTP endpoint. This one happens to be a post to my error handler. And I'm going to post a message saying that there's a schedule error. I've defined a retry policy. That retry policy is fixed. It's going to run every hour 5 more times. It's going to retry 5 times. And the job is starting the enabled state. This job will start, well, in this case, it's starting in the past. But the frequency is every month until the end of the year, right, 2014, 12/31. And it's going to run at 8:30 and 5:30, and only run on the last Friday of the month. So this is what, it could be a little bit more complex because you can provide some more information into the prescribed schedule section. But it doesn't get much more complex than this. So this is probably on the high end of your complexity of a job. But the simplest job I could think of is this one. It has an action that's going to go hit Bing. It has no start time, has no recurrence. We'll just run once and then complete. But that's the simplest job that you can, your hello world job for running a scheduler service. And the last part in the entity hierarchy is the history. The history shows the results of the job occurrences. So we give you information like the execution status, what was the start time and end time of the occurrence, what was the response that we got back from the endpoint. For the server stores about 2K of the response. It's usually most interesting when you have error responses. We store that within the service so you can go and see what's the error that you got when there was something wrong in the back end. We provide in the API a way to filter the execution status. So, if you have thousands of occurrences, the things that may be most important for you are the failures. So you can apply a failure filter, and then we'll only give you the failed job history entries back. We maintain the last 2 months of job occurrences. So that's what we have in our backend store. And on the URI we have at the very end for a particular job, you can get the history for that particular job. So now I'm going to go into a demo, and in that demo I will actually go into Visual Studio and show you some of the details of the job. And in this scenario, what I've done is I've created 2 cloud services, one in East US, one in West US. Those cloud services are listening on queues. One's called the East queue and the West queue. And each time it reads a message off of that queue, it's going to go and push it to a blob store just so that we can see that it's actually doing some work and it's actually running. And in the demo, what I'm going to do is I'm going to make one of those queues unavailable, and then you'll see the job that's supposed to be going to East US will stop, and then West US will pick up the job because it's going to fail over to the West queue, but then continue. So you don't get any interruption in your jobs that you've created. So let me move over to my machine. And go to the portal. So the first thing I'm going to show you is that I have 2 cloud services, East and East backend and West backend. And in the portal, you can scroll down and you'll see the scheduler icon for your schedule service. So here's where we list all of your job collections. I've already created a job collection called Demo Jobs. This is the job collection I'll use today. And the first thing you get is a dashboard. So I've purposely done some interesting things in the back end so we could light up some of the meters that we have here. The first, it'll tell you the number of jobs that you have in a job collection. For a standard job collection, you can have up to 50 jobs in that job collection. In this case, I have 10 jobs out of 50 that's in that job collection. This is telling me that 4 of the jobs have completed. So I have a completion rule either by an end date or by a count, and those jobs have been completed. 2 of my jobs have faulted. That means it tried really hard to reach that endpoint, but for some reason, it never worked, and so it went into the faulted state. I don't have any jobs enabled yet. I'm going to go ahead and do that soon. And I have 4 jobs disabled. This is just warning me. It's like, oh, you might have forgotten that you've disabled some jobs. Go ahead and re-enable those. And throughout the executions of my 118 executions, 81 of those were errors. So one of the very useful pieces of information here is this URI. So as we were going through the explanation of the REST URI, this is it right here. So I'm going to go ahead and copy that. And you could take that REST URI and go to Fiddler. Oops. And I'm going to look at the jobs in that job collection. Voila, that's done. And now what it's showing me here is the set of jobs that I have defined in that job collection. So if I've gone back to the portal, you can see this list of jobs that I have here. So this is the same interface that the portal uses, and it returns the same information. So we have the collection of jobs. Here. So this goes on and on. We have our 10 jobs. So great. So what can I do with that? Well, what I really want to do is create a new job. Of course, I can go to the portal and go, right through the wizard experience for creating a job. But that's not so interesting. Let's actually go ahead and create some JSON and define that job on the fly. So here I am in Visual Studio. This is VS 2013 with RC Update. And I have the project open where I've created my worker roles. If I look at some of the code for my worker role, what I've done is the worker role is pretty simple. It's going ahead and reading the messages in that queue, and then it's going to go interrogate the job definition. And as part of every queue message, we give you a bit of data about the job that's running. So in this case, I'm extracting out of that message the scheduler job ID, as well as the expected execution time of that message. So we give you that data as part of the message. And I'm going to use that data and concatenate it together to create the name of my blob that I will push up to Blob Store. So let's go ahead and create a new job. One of the things I'm really excited about using today is in this RC update, we now have in Visual Studio a JSON editor. Yay. To show you the power of the JSON editor and how easy it is to create a job, and I'll go ahead and describe some of the capabilities of the scheduler service by going through the actual JSON itself. I'm going to go ahead and create a job by hand. No copy paste, nothing up my sleeves. So, first thing. So at the top level, we can create an action. Can you all see that? We can create an action, a recurrence, a start time, and a state. So I'm going to go ahead and create an action. That action is an object. And in that action, I'm going to describe what is the thing that I want to invoke. So I'm going to pick a type. And I have a set of types that I can pick. Let's say if I pick an HTTP job, I will then have a request for that HTTP job. And as part of that HTTP request, I have a URI. So this is the endpoint I want to reach. For example, I can reach out to bing.com. Then I have the method that I want to call on it. And we support any of the methods that you can execute on a URI. This time I'll do a get. You can supply your own set of custom headers. I don't have any headers for this get. And then a body. A body for a get doesn't really make sense. So a body only makes sense for a put or a post. So that's a very simple HTTP request. That's not what I'm really going to demo, but I just wanted to go through that so you could see what was available for you in an HTTP request. What I'm actually going to do is create a queue message, a queue job. So this is going to be a storage queue type. It's going to be a queue message that I'm going to send. Now, the queue message now has a bunch of parts that I need to describe as part of that queue message. First is the storage queue, the storage account that I want to send to. So in this case, the storage account this is my storage account. Then the queue name that I want to send. I've already pre-created a queue called East Queue. Oops, if I spell this right. Let's hope that typos don't kill my demo. And then to be able to give permission to the scheduler service to actually reach out and send messages to that queue, we have to provide a SAS token. And I'll go out to PowerShell and come back and put that SAS token in here in a second. And then finally, the message that I want to provide. Oops. Do work from the east. That's it. So that describes my action for being able to send a message to a storage queue on the Kevin account called on the East queue. And I'll come back and fill in the SAS token. But I'm not done yet. I want this to be a really complex one, so I can go through the details and explain some of this information to you. So the next thing I want to do is provide a retry policy. So even though there's a built-in retry policy, it may not be the policy that I want. And for demo purposes, I actually want to tweak that a little bit to make sure we have side effects occurring faster than expected. So the first thing I can choose is a retry type. That retry type can either be fixed or none. So if you don't want it to retry at all, you can just say none. In this case, I'll pick fixed. And you can also supply a retry interval. I'll use the default interval, but this time I'll use a retry count of 1. So in this case, if there's a failure, only retry one more time, and then go to my error action. So now let's define the error action. Here's my error action. So the error action looks just like the main action in that you can define the type of action you're going to do. In this case, I will again do a storage queue action. I'm going to send it a queue message. It's going to be the same storage account. And this time the queue name is going to be the West queue. So it's going to fail over in case it can't reach the East queue. We'll then try to go reach out to the West queue. And every queue message needs a SAS token. I'll come back and fill this in a second. And then I'll give it a message. Do work from the West. That's it. So now I've essentially created a highly reliable job definition. But I'm not done yet. I have to give it a schedule. What's the reoccurrence plan that I want to give it? So down here, I'm going to pick my reoccurrence. And in my reoccurrence, I can now specify the schedule that I want to pick. So let's say we're looking at that in the DEX I showed you a complex schedule, so let's go ahead and create that complex schedule. Here we can pick day, hour, minute, month, or week. I'm going to go ahead and pick month. And then the interval that I want that to run at. So I'm going to have this run once a month. And I'm going to give it an end time. I want this to run till the end of the year. Now, not only did I want it to run monthly, but I actually wanted to prescribe that schedule of when it actually would run during the month. So here, this is where you introduce a schedule in your reoccurrence. And this is where you get your more complex scheduling capabilities. So I wanted to run at, what did I say, 8:30 a.m. and 5:30 p.m. So let's go pick hours, which would be 8 and 17. And then minutes, because I want it to run in the half hour. So now it's going to run into 8:30 and 5:30. And I only want it to run on the last Friday of the month. So in this case, this is going to be an array of recurrences. And I can pick the day. Oops. Day. What's going on? Oh, there we go. Fat fingered. And I want it to be on last Friday. And I want it to be on the last Friday of the month. So occurrence, and you say -1 means it's the last Friday. If I picked 1, it's the first Friday of the month. And that's it. I've just described a complex schedule where my job will run from now until the end of the year, every last Friday of the month at 8:30 in the morning and 5:30 p.m. So in 6 lines of JSON, I've been able to describe that complex job. This is not the job we'll use because we'll be here for a long time in this demo. So let's go ahead and delete all this stuff. So instead of running once a month, I'm going to have this run once a minute. So that's it. I've now described, here you can pick a state, it's disabled or disabled, but by default, it's enabled by default. So now I've described a job that will run once a minute. It will try to reach out to the east queue. If that east queue is unavailable, it will retry once in 30 seconds. If it fails to continue to be able to reach that east queue, then it will go to the error action and hit the west queue. So let's go ahead and copy this job. Let's go back to Fiddler. So all I'm going to do now is, before we were looking at our jobs, I'm going to go ahead and create a new job. Build demo. See that? Build demo. This is going to be a put request. And I'm going to go ahead and just drop my JSON in there. Execute it. Oh, I mistyped something. What's great about this is that you can actually see what went wrong. I forgot to add my SAS token. Awesome. So let's go back to my job, and I'm going to bring up PowerShell and say I want to create a new SAS token. So new Azure Storage Q SAS token. I want this for my east queue with a policy of add, and I want it to expire this weekend. policy. My mistake. Permission. Okay, so I got a storage queue. So I'm going to do the same thing for my west queue. So now I have 2 storage keys. I'm going to go ahead and copy these guys. Paste that guy in there. Paste that guy in there. Let's go back to Fiddler. Okay, let's try that again. Great, it accepted it, 201. Yay. So if I go ahead and I can get that job back, we can see it actually had been created in the service. So this is the job that I've just defined. And you can see it all defined here. So now that job is running. So if we go to the portal, and I go and select my job history, we see that the first occurrences have already run. So now this job is running. I go to my blob container. I had a couple runs here before. Let's hit the right button. And so now we see that the job is running. It's actually pushing work to the back end. So my east compute service is actually pushing work to the back end. So what happens if I go ahead and delete that east queue? Yes. So now the scheduler service is trying to reach out to that east queue. It's going to be running once a minute, and it's going to realize that it can't hit that east end queue. So if we go back to the portal, hopefully I caught it in time, the portal will go ahead and try to reach that east queue, and it says it failed. I can't reach that east end queue. So this is the first attempt that it's tried. It will try once more. I have to wait 30 seconds. But in the meantime, we can see in here that one of the things that you can show is that the content of the message, right, if I go ahead and look at the content of that message, you could see all the information that we give you as part of that message. So by default, we give you the information about the client request ID, the expected execution time, the scheduled job ID, the job collection that it was in, what region it did it run from, and the message that we sent. So then there's some default information that you can use. Of course, the message itself that we said was the message from the east. Go back to our portal, we can see that it failed, so it retried going from the east queue, and it failed over. Now it's trying to send messages to the west queue, and now that's succeeding. And in the back end, the west back end is continuing to do its work. And then we see that a new message going to the west back queue is working again. And we can actually go ahead and recreate that queue, and it will just continue to work. So what I've shown here is that you can go ahead and create highly reliable jobs in our service. We will honor your retry policies and the actions that you described. You can define a job with complex schedules and have our service reliably run that job. So that's it. That's the demo. Let me go back to my PowerPoint. So what are other Azure services that are powered by the Azure Scheduler service? So, with the Azure Scheduler service being a platform service, it is a core Azure service. We have other services that are actually using the Azure Scheduler service. If you guys are using the mobile service schedule scripts, the schedule scripts is actually using the scheduler service in the back end to do that scheduling work for being able to fire your JavaScripts on your mobile apps, on your mobile services. The new website scheduled web jobs. So in the keynote, we talked about the new web jobs capability in websites. You can actually schedule those web jobs to fire on the schedule that you like. That schedule is actually being run in the Azure scheduler, and you can go ahead and schedule web jobs on your websites. Other Azure management scheduling capabilities that we have in the portal, for example, scheduled autoscaling. Autoscale, you can define the schedule at which your scaling will occur at. In the back end, that's using the schedule service to determine what that schedule is for when it should actually autoscale your websites or VMs in Azure. Scheduled website backup. So there's a new preview feature in websites where you can have a schedule for backing up your websites. That, again, is using scheduler service in the background. And as well as the scheduled SQL Azure database backup. So if you back up your SQL database on a schedule, again, behind the scenes, that's using the Azure scheduler service. But not only is our Azure services using the scheduler, we also have partners in Microsoft and customers outside of Microsoft that are using scheduler for their workloads. So for back-end scheduled workloads, and by back-end scheduled workloads, meaning I have a service that's in the cloud, and on some occurrence, I want to be able to do some back-end work. And I have some cleanup work or some other things. For example, Xbox Video is using the schedule service to schedule video publication content checks. So they have content providers that are providing videos for their service, and they use the schedule service to go to let them know on a schedule to go check to make sure that those content providers are providing the videos at the time that they said they would provide them. The Skype data team is using the scheduler service. They have mounds and mounds of data, and they want to be able to process that data. And so they use the scheduler service to kick off Hadoop jobs that will then go and crunch through the data that they have collecting in the back end. One of the other things that we have is the ability for applications to go ahead and integrate new scheduling capabilities within your service. We've been working with a customer called GoForms. GoForms has a new feature in their service. What GoForms is the ability to manage, it's a multi-tenant service that allows you to manage forms up in the cloud. And they've provided a new scheduling capability so that each user can go ahead and define a schedule at which reports can be generated and then emailed to you. And so they have thousands of jobs that are going to be running in the back end because it's going to be mapped in their multi-tenant service to each of those services. So they have a job collection per user and a number of jobs that are defined within that assigned to each user. So what are some scheduling options in Azure? So we have, I've described some of these other services that are using scheduler, and I get questions asked about, well, where should I actually run my workload? So for mobile services scheduled scripts, the intent of the scheduled scripts is that you have scheduled workloads that affect data within the mobile service. They've created a lot of convenience capabilities in the language and how those jobs get executed so that you can affect the data within that service very easily. Website scheduled web jobs. So again, it's typically the work that you want to schedule for web jobs affects the data or processing within the website. So either it's invoking some cleanup on the back end or doing some workload that's one-off for your website. You can also use it as a simple way to host lightweight jobs on your existing website. So if you already have a website and you have some script that you want to run, it may not necessarily be associated with that website, but it's a really easy way to go and host your script or your code. You don't have to bring up 10 worker roles or a VM to make that happen. The web jobs has a nice SDK, so you can go ahead and have a nice programming model for being able to describe your web job. Finally, if those two things, those criteria doesn't meet it for you, For example, if you have a pre-existing endpoint, I already have a service that's up. It's not on Azure websites or a mobile service, and I just want to be able to invoke that endpoint on a schedule. That's one of the scenarios where you use the schedule jobs. I want to invoke workloads on other services. For example, if I have Web HCAT in front of my HD Insight cluster, I can run Hadoop jobs, and I can schedule a job to actually go ahead and invoke that Hadoop job. I want to invoke heavier workloads on worker roles using a storage queue. So one of the advantages of being able to push work to a worker queue is that the backend doesn't have to be up at the time that the request is made. So if either your backend is down for maintenance or it's busy doing work, that message will be queued, and then the backend can come when it's ready to go and process that request. Or in the other scenario that I have a very heavy workload where it's doing a lot of data processing, for example, or very timely type of work, doing some SQL analysis, you can actually scale that out in the back end and it will continue processing so you can do work in parallel. So here's some resources. I have some Channel 9 videos, both in the Cloud Cover Show and in Azure Fridays. I also wanted to leave some time for Q&A, but I just want to give you some information here. And I'm supposed to plug John Gruber's podcast. He's supposed to release some exciting news today about his service. So now I'm going to leave the rest of the time for Q&A. So if anybody has any questions, please come up to the mic and I'll be happy to answer them.
Do you have support for schedules like, I saw that the schedules the complex schedules you have are kind of cron-like expressions?
Yes.
Do you have support for something like, every Monday at 8 a.m. and every Wednesday at 5 p.m. or 5:30 p.m., even better?
Yes, we can do that.
Okay, all right. And that's covered in your unusual schedules?
Yes, you can create a schedule that has that complex schedule. Correct.
Okay.
The question was, are there any limitations on the schedule you can create? I have to repeat that to make sure that it's being recorded. So I'm not sure what type of limitations do you mean?
How complex can a schedule be? Can you say that one day you want to work at this hour, but the next day you want to work at a different hour?
I see. So one day if it can work at 1 hour, another day you can work at a different hour. You're getting into kind of overlapping schedules, right? Because remember, this is going to be a reoccurring schedule, so it has to have some consistency in how it reoccurs. The recommendation for those things that overlap is actually to create 2 or 3 jobs that happen to have that right scheduling capability. But as long as you can create a consistent reoccurrence, even with these complex rules, then you can do it in one job.
One of the scenarios that I was actually looking at with the schedule service was to use it to kick off a CRM 2013 action on CRM Online. I don't think you necessarily have to use a worker role to do that. How would you best do something light like that, like kicking off something on another online service?
So the only thing that you have to have in mind for connecting to another service is if it's reachable through Azure, then we can go ahead and reach it. We have to make sure that the right authorization or authentication can happen. So if it doesn't do basic auth or can take a token in a header, then you have to have a script that will actually do that authentication work for you.
Okay.
For the HTTP action, is there a timeout? If, let's just say you're too lazy to do a queue or anything like that, and you have a long-running process, is it the 30-second thing we're all used to, or?
Yeah, so for any HTTP request, the HTTP request does have a web request timeout of 30 seconds. So the intent behind an HTTP request is that it's intended to go and invoke that backend service, and if it has long processing to do on that request, it would honor the request and then do the the
Sure.
work in the background.
Okay,
Otherwise,
great.
we'll time out.
Thank you.
Yeah?
Is there an API available? .NET?
Is there a .NET API available? Absolutely. We have a .NET API available, and you can download it from NuGet. It's in the 1.0 package of the Azure Management Library.
Is it just one schedule per job, or can a job have more than one schedule?
Today, each job can only have one schedule.
So job collections. I was wondering if you are able to define the sequences there inside a collection. Like I want to say job one run first, if it's run successfully, and job 3 run next.
So the question is about job sequencing. Today, we don't support job sequencing, but that is something on our short list for being able to add. For example, the job definition itself may need to go out to reach to one particular endpoint to get a cookie, and then take that cookie and then pass it into the actual work that you want to do. That's a very common scenario, and that's one of the things that we're looking at very soon.
Okay, how about job chunking?
Job chunking.
Meaning that I have a long running job which could last for 10 hours, and I need to chunk it, those kind of concept.
Well, one of the things that the other gentleman asked about what the web request timeout was, and we said it was 30 seconds. Another request that we have from customers is for asynchronous long-running processing, so that if I make a request and I want the work that's being done in the back end to be actually reflected in the success or failure of the job, then we need a protocol for doing some asynchronous long-running processing. So there's already a protocol for that, which is you return a 202 with the retry endpoint, and then we'll go ahead and retry that. So that's one of the other things that's on our short list for being able to enable long-running processing that can participate in the success or failure of a job.
Okay, regarding to the failure of the job, is it really scheduling failure, or is it really job execution failures? I already scheduled job to be run successfully, but job execution got failed.
Yeah, so
Would that be considered a failure of the job? That's really considered success of scheduling, but failure of job execution.
yes, when we do the asynchronous long-running processing, we will reflect both that the job was able to start, but then failed to complete. So we'll have that in there. Today, if the success of a job saying it's completed means that it was able to make the request and got a successful response back. If we got a 400 or greater response, then we would consider that occurrence or failure.
Okay.
request.
Another is when you're creating the job, are you able to create a context information? Like when my job starts execution, I need to have context information. So part of job definition to put the context into the job.
Which kind of context?
Context data like the environment, where I'm from, my user ID, stuff like that can be put into the job when you define it. That way you got context information.
Yes, you can either add that information to the header yourself or to the body of the message. There's some default header information that we give you about at least the environment of the scheduler service. So we'll give you job ID, job collection name,
Okay.
and expected execution time. Yeah.
Okay, our last question. This is for the Azure, right? This is scheduled for Azure. Is there API for the window? Like if I need to have a scheduler on premises instead of running under the cloud, is there such a thing like that?
So I think your question is, does the Azure Scheduler Service run on-prem?
Yeah.
No, it does not today. Our intent is soon, when we integrate with what was announced today with the Resource Manager and the new portal, everything that's available in there will also be available on-prem through Windows Azure Pack, but not yet.
Okay, thank you.
Another question? Any plans to support Service Bus? So yes, that is another top request that we have from customers. We picked Storage Queue first because that was a core service, but Service Bus was the next action that we'd support in our service. Okay, perfect timing. I have 30 seconds left. That's it. Great. Well, thank you, everybody.